An extension of what we did yesterday. More properties of parallelograms. Okay, 6.2b. What I have are, I think it's 2 theorems in this section. Yes, 2 theorems. Again, I don't care. Yeah, I don't care if you remember the name of the theorem or not. It's Theorem 6.6. I'm not even going to write that down. What we're doing, this essentially what you could do with this one is you could tack this onto yesterday's notes as number 4. Remember we did if a quadrilateral is a parallelogram, then there were 3 things. Here's number 4. If you want to just tack it onto yesterday's notes, you're welcome to do that. But here's what it says. If a quadrilateral, that's quadrilateral, is a parallelogram, then its diagonals bisect. Oh, that didn't work out well. My hand touches it down here and then it moves. Silliness. Okay, if a quadrilateral is a parallelogram, then diagonals bisect each other. Here's what that means, okay? If I have this figure, and I am told that these are parallel and these are parallel, right? So this is a parallelogram. If I draw the diagonals in, this diagonal and this diagonal, they bisect each other, meaning that this is congruent to that, and this is congruent to that. So diagonals cut each other in half. Okay, so you'll have equal parts and equal parts. That makes sense? Okay. So what you're going to have to do with those types of problems, this is like example 3 in the book. They'll say solve to find A and B. And here's your picture. Okay, this is a parallelogram. So they'll either tell you it's a parallelogram or they'll mark it for you. We'll just mark it for you. If I tell you this is H, K, J, and I, and the diagonals are drawn in, and this is A, and this is B, and this is 2B minus 8, and this is A plus 2. Okay, so we have all this information in a parallelogram. What do you know about the diagonals of a parallelogram?
Well, they bisect.
They bisect each other. Okay, so the parts are equal. Now, what you have to be a little bit careful with is your variables. You have A's and you have B's, and neither of them you can set equal to each other with both A's or both B's, right? So what am I setting equal right now?
A plus 2 to 2B.
A plus 2 equals what?
B.
B, right? A plus 2 equals B. This one here is the same as this one here. So A plus 2 has to equal B. Okay, so we know that's true. What's the other one?
A equals 2 minus 8.
And then A has to equal 2B minus 8, okay? Neither one of those are solvable on their own, but you know substitution because we love algebra. So we can substitute wherever we want. You tell me, which one would you rather substitute into? Do you want to take this expression and put it in for A?
Yes.
Or do you want to take this expression and put it in for B?
The first one.
Oh, yeah, the first one. The second one.
I would say, technically, for me, I would say the first one's easier. But it's up to you. You can do it either way. There's not a right way and a wrong way. No, there's not. Okay, so I will do it the first way. This is our A, right? We're going to plug that in right here. So it's going to be 2B minus 8 plus 2 equals b. Okay, so then you just simplify. Negative 8 plus 2, so 2b minus 6 equals b. I'm going to take away the 2b to keep my 6 over there. What's b minus 2b? Negative b. Negative 1b. If you want to put the 1 in, you can. So negative b equals negative 6. Divide by negative 1. So b is 6. Okay, so we're just substituting there. If b is 6, then you come back up here, and you can plug it in here, or you can plug it in here. Doesn't matter. So if a has to equal 2 times b, which is 6, minus 8, then you get 12 minus 8. A is going to be 4. Okay. Well, you had to distribute on the first one, or the second one. Questions on that? If you are struggling with substitution, talk to me. Okay, that's algebra. You've learned that last year, but we haven't covered a whole lot of substitution this year. We've done it, but not a lot. So if you're struggling with that, talk to me. So if they ask me what HJ is, what is HJ?
That's a great question.
Hold up.
Wait.
HJ. Oh.
But that one's next to
HJ is
Oh, I know.
4
Eight.
plus,
I said it first.
HJ is 8.
I said it
Yes, because A is 4, right?
and that one bisect.
And they're the same, so 4 and 4. So HJ is 8. Okay. What is IK?
12.
Would be 12. B is 6. So this one is 6 also. 6 and 6. IK would have to be 12. Okay? Questions on that? Okay. Then our second theorem is theorem 6-7. Again, I don't need you to know a number, but I'm just going to write this one out because this one, yeah, is a little bit different. This one says if 3 or more, you can have more than that too, parallel lines, if 3 or more parallel lines cut off congruent segments, on one transversal. What's a transversal? The line that cuts through the other lines, right?
Yeah.
So if they cut off congruent segments on one transversal, then they cut off congruent segments on all transversals. I'm going to show you. Okay, so here's what the theorem is saying. If I have parallel lines, okay, these are all parallel. If I were to draw a transversal in right now, so the blue is my transversals, okay? Here's a transversal. What they're saying is if the segments created by the parallel lines on that transversal are congruent. So if this segment here is congruent to this segment here, then it doesn't matter what other transversals I draw in, they will always cut off congruent segments. Not congruent to those first two necessarily, but congruent to each other. So let's say I put a segment like this, right? That one would make this segment congruent to that segment. If I put one straight up and down right here, that would make this segment congruent to that segment. Okay, so it is not that this would be congruent to this would be congruent to that. Those are not the same, okay, because those are all cutting at different angles. You're going to have different lengths. What is the same are the ones that are on the same transversal, okay? So if the distance is the same between them, it will be the same on all of them. Questions on that? Okay, so here's my question then. I will draw you another picture here. This is example 4. Oh, I don't want green. let's say we have these parallel lines. Indeed.
It is indeed.
All right, so this is point A, point B, point C, point D, point E, point F, point G, point H. Okay, so they're all meeting. This is what we know. If I tell you AB equals BC, which equals CD, which is a length of 3. Okay? And then I tell you EF is 2.5. I want to know the length of EH.
Wait, each?
EH. So AB is 3, BC is 3, CD is 3, right? 3,
Where's the end, though?
3, and 3.
Where's the end?
E is this point. They're all points. E, F, G,
Oh,
H.
I understand.
They're points, right? Okay, so if all of these have a length of 3, what's true about all of these?
They're all the same.
They're all the same. They're all 2.5, right? So EF is 2.5. I want to know EH. I want to know that whole segment. Well, that means this is 2.5 and this is 2.5. So if I want to know EH, I just need to add those 3 together, 2.5 times 3 or 2.5 plus 2.5 plus 2.5, however you want to look at that. That would make EH a length of 7.5. Okay. How about this one?
Can you move it?
In a minute. Let me pretend this line is straight. That doesn't look very straight, does it? Pretend. All right, so in this picture, if FE is 4, what's FD? It would be 8, right? Because these two are the same, so our parallel lines are just going a different direction now, right? That means these two also have to be the same. So if FE is 4, then so is ED. So that would make FD 4 plus 4, or 8. Okay? Questions on that? Okay. That is the lesson for the first one. That's all of 6.2b. I will give you a few minutes here to start on that one, see how you're doing with it, and then I'll teach you the 6.3 in just a little bit. You can probably move on to the 6.3 if you finish the 6.2b on your own, because it is just the converses mostly of what we did yesterday, but I will teach them to you in just a little bit.